Hi gang, Eric here again. This time I've got another stoichiometry example for you, and I'm going to solve it for you two different ways. First thing I'm going to do is I'm going to solve it sort of the traditional way, which uses a bunch of fractions and equations, and then I'm going to solve it using what I call the Stoich chart. Okay, so let's say you're given this question. How many grams of water are produced when 100 grams of methane are combusted? Well, the first thing, you're also going to need to know one thing. You need to assume that this is a complete combustion, otherwise it's a slightly different chemical reaction. And let's further assume that you've been given the chemical equation and it's already properly balanced. Let's switch to my notebook, and I've got the equation already set up, so let's add in what we know. We know that there are 100 grams of methane, CH4, and we know that the molar mass of methane is 16 grams per mole. You should know how to do that from another video, or you've already had practice. And let's go ahead and label the different things that they are. I use a lowercase m for mass and a capital M for molar mass. And we also need to know the molar mass of water. That's, of course, 18 grams per mole. And now we need this thing called a molar ratio. And the molar ratio is just how many moles of one thing translate to how many moles of the other. So in this case, 1 mole of CH4 will translate to 2 moles of H2O. So we write that down as a fraction. We'll need that later. And then let's take a look at what equations we're going to use. Here's my favorite, the M&M equation. Mass equals moles times molar mass, or moles equals mass divided by molar mass. Let's use that one. So we need to find the moles of methane. So 100 grams of methane, and this time we're going to divide it by the molar mass, so 16.0 grams per mole, and that gives us 6.25 moles of methane. It's important to keep track of the chemical, so that's why I keep writing what chemical we're talking about. So now we have to convert the methane, the moles of methane, into the moles of water, and that's where the molar ratio comes in. 2 moles of water over 1 mole of methane. So what that means is when we multiply that out, we get, nope, that's not it, it's 12.5 moles of water. So now we're going to take that, and we can take the moles of water, and we can turn that into grams by using the molar mass. This time we'll be multiplying, and we wind up with the answer we were looking for, 225 grams of water. Now this is a perfectly valid way to use this, to solve this problem. But I think there's an easier way, but it involves a thing I call the Stoich chart, and not a lot of teachers use that. So let me show you what I do. Here we are back with the chemical equation again, but this time you can see I've got my chart set up. Now to explain, I've got one column for every chemical, but then these 5 rows: grams, grams per mole, mole, molar ratio, and moles of reaction. Now they might be new, so let's see where they come from. This molar ratio is just the numbers we use to balance the chemical equation. And I write in the ones this time. Okay, so now let's see what we know. Well, the only thing we knew from the problem was the grams of methane. So there's the 100 grams of methane. Now it's grams of methane. You got to look at both the left hand and the top. So writing it out this way, 100 grams of methane is the same as putting it into that square in the box. Now what else do we know? We know the molar masses. So we write in the molar mass of methane, the molar mass of water. Okay, so how do you use the chart? Well, here's the great thing. Divide, you go down, you divide, you go up, you multiply. And that's it. So you play leapfrog here. So we go from the grams, we're going to go from grams, divide that by the grams per mole, and we get the moles. Now we take the 6.25 and we get this mole of reaction. So what is this thing? Well, a chemical equation is basically like a recipe, and this mole of reaction here tells you how many times you're going to do the whole reaction. So it's sort of like doubling a recipe, or in this case 6.25ing a recipe, and it applies across the whole equation. So in an ideal stoichiometric reaction, the moles of reaction is the same for everything. So that's the beauty, and that's what lets us go up in the different column. So we just take the 6.25, multiply it by the 2, 12.5 multiplied by the 18, and we are back to getting the answer. So that was a real quick way to go through this. Oh, let's write out the answer. I'm going to explain this a little bit more in another video, but thanks for watching.